Computer. Guten Tag. Das ist ein Byte relay, and sorry, that's all what I know in German. Today, our guest is Johannes, and he is author of the database SirixDB. Hi, Johannes. How are you?
Hi, I'm fine. Thank you.
Cool. Uh, so you are doing databases. Is it correct?
Yeah, in my spare time, a little bit.
Cool. Yeah, I'm
So,
I'm doing databases in my spare time too, and in my work time. And all the rest time I'm doing databases. They're so funny. Please tell us something about yourself. Who are you? What do you do? And why databases? Why do it?
yeah, I'm Johannes, and I've studied at the University of Constance, and there basically we had two systems for, yeah, back in the day it was all XML related. Um, there's a smaller database which is, I think they have some customers, and it's a spin-off of the university, but very small company, I guess. So it's SpaceX. Maybe, yeah, I don't think it's very
I
well
think
known.
I heard something, but do not remember what exactly.
Yeah,
So you was
yeah,
developing a
and
database for university.
yeah. Um, Basically, it was at first it was Mark Ramis, a PhD student, which came up with the idea. And afterwards, it was Sebastian Graf, which did his PhD and with a secure cloud storage.
Mhm.
And yeah, I was a bachelor and master student there and did my bachelor thesis and master thesis in the project and the projects on the product. So
Mhm.
uh, and after university, I basically I forked the project because it went into the secure cloud storage area without
Mhm.
without the database stuff.
Mhm.
So yeah,
I see. Uh, it's just always interesting. Are you interested in anything besides databases? What hobbies do you have? What ideas or real what is interesting for you besides databases?
yeah. Besides, I'm dancing a lot now since
Cool.
Corona, not that much anymore, but I want to start again. So I did a lot of Lindy Hop swing dancing.
That
Uh,
really sounds unusual. Like maybe
mm,
databases is kind of a byte dance. too.
yeah, but actually there are a lot of software engineers, I think, which are dancing Lindy Hop because it's something completely on the other side.
Mhm.
Uh,
Could you, like, for areas of computer science, map something to dances like machine learning is one dance, databases is other dance, and algorithms is third dance? Maybe it's just a random idea.
I think between algorithms and databases.
And which dance is which? Lindy Hop or
Lindy Hop, I don't know. It's a hard
okay,
question.
okay. So tell us please something about your database.
Um,
How you just started it, why, and what is it, how it works?
yeah, it's a versioned database, so it's all about storing, each commit stores a lightweight revision of the data. So in principle, it uses like, I think the Atomic uses a functional data structure underneath. Um, so basically you have a try, and in this try there are 64-bit node keys. stored with the data, the nodes itself. And basically, you can now store XML or you can store JSON.
Is it really a database, or it's like you have some dialect for manipulating data?
You mean the query language, or?
Yes.
Yes, the query language is JSON-IQ, JSONic, which is an XQuery derivative for processing JSON. Yeah, so tree structured data.
As it's kind of a, now it sounds like a good idea to have a pre-structured language that do not need parser. Did you invent this structure yourself for your query language?
What was the question?
Did you invent the structure for JSONic yourself?
JSONic has been invented by, I think, in Switzerland at the ETH Zurich.
Ah, I see. So you had a language and you implemented it in your database.
Yeah. So basically it was, I think it was meant for XQuery processors and to simply adopt the XQuery language for also processing JSON. But I've used the project from TU Kaiserslautern. It was this, I think, a PhD student under Theo Herder. So Sebastian Bechle did the query processor initially, and I modified it to work with JSONic. And with I did the data store binding and a lot of stuff regarding the JSONic data model, which was a bit different to his approach.
I see.
And I've added a lot of temporal enhancements. For instance, for JSON, there are functions, and for processing XML, you can.
So you not just adapted the pre-existing language, you advanced it. You created a new version of it.
Yeah, but for XML, I've added some XPath temporal access. So normally in XML, you can do some descendant access, a child access, following access, preceding and ancestor and parent access. But I've added first, last, before, next, future.
Did you add it to open source version or just in your database? Like, did you share new knowledge that you acquired through working with it?
It's in my database, but it's also based on an idea from, I think it was the same guy that did invent the JSONic. I think he also did a time machine, XML time machine project at the ETH Zurich. And I've read a paper, so
I see.
And for JSON, I've simply added functions. But functions are in the JSONic language.
I see. I read some. You have a very decent documentation. Your database contains so much of information, how to use it and how about its details. So it's really it's great compared to many other open source projects.
I don't know.
And actually, reading, I see that you say that there is some novel page level versioning approach. Did you invent this approach, or did you read some paper or write some paper about it? What's novel in this?
Mark Rames, which did the first iteration of the project, did invent it, and I think it was also patented, but we have implemented in a slightly other way, I hope. But yeah. Yeah, and he came up with this with a sliding window algorithm. You may know from backup systems there are incremental versionings, full versionings, and differential.
If you wish, you can show us something on if you want to share a screen, for example. But if not, we can just continue with interview.
Maybe I have nothing related to this algorithm in particular, but I can share.
Yes, I see.
Yeah, it's basically on the left, there's a JSON string I want to store in the database. And I think in comparison to MongoDB, in MongoDB it would be basically one document and
it's one bunch of bytes.
Another embedded document. And I've ported an encoding from XML database systems, more or less, which is first child, last child, parent, left sibling, right sibling encoding. So basically, first virtual document root node is created, then the object node, so it's pretty fine-grained in the system. And so I'm creating an object node, then an object field node with the name field1, and an object value node with the value 2. And basically these are doubly linked lists, more or less. So from field 1, you can fetch field 2, field 3, field 4, and first child and last child is, in this case, it's the same object node. And in this case, for field 3, it's the array, the first child. So we have a few axes, how to traverse the tree in a pre-order traversal or in-order traversal, level order traversal, and so on.
I see. So this structure is optimized to get details of some internals of JSON object and to update cheaply only part of a JSON. Currently in Postgres we have a big problem that we support JSON, but if you want to, for example, increment counter in JSONB object, you have to decompress the whole string, change these bits, compress it back, and store it to those table. It's very costly operation. So in Postgres, it's kind of a problem. Maybe we could adapt something like that to make JSON manipulations cheaper. But so far, it's just a byte array that have to be replaced in the whole.
Okay. Yeah, basically, for instance, if you delete this field 2 or some, you might simply delete this from the page, and you have to adapt the left child and the right child to adapt the pointers. So the object field with field 1 points to field 3, and field 3 points to field 1 after this one is deleted. So in total, you have to adapt this node, and this node, and maybe the parent node, because we SirixDB optionally stores hashes, and the descendant count plus a child count of each node. But in general, the idea is to have really cheap update operations and to only store a couple of nodes which have changed if you copy the page in which these nodes reside, then only these nodes are written, and nodes which fall out of the sliding window in this new versioning algorithm. So basically, to reconstruct a page in memory, you might have to read up to a certain threshold of page fragments. I've called it page fragments, but
I just don't understand. Where are pages here? So what is page?
no,
Page.
actually there's no page, but these nodes are stored in the leaf nodes of a trie. So basically they are monotonically incrementing just a sequence generator which numbers them 0, 1, 2, 3, 4, 5, somewhere 6 must be, maybe. And
yeah, probably it's there. Okay, I understand now how it works better. And so you are using for different.
I can show a little bit the logical page structure, which is like you have a revision root pointer, which points to the first indirect page. Basically, it's a tree of pages which just point downwards into the data page fragments, which have the nodes in it. So basically, it's an array, but stored in a trie, so to say. So in each of these pages, there are currently 1024 pointers to other pages. And every time the number of nodes which are stored is higher, then it's possible to dereference a new indirect page is added on top. So that you can always dereference them. And yeah, usually, let's say a node in data page fragment in this data page fragment has changed. Then you have to copy the whole path up to the root. Yeah, which might contribute to write amplification, but we are storing a random size page, not fixed size page. So it might be a little bit as in the new system of UmpraDB, for instance, from Thomas Neumann. And now the new thing is that every time you change here in this data page a couple of nodes, you will only have to copy this couple of nodes to a new data page fragment, which is in this case, in the third revision, we are updating the new page in this one. No, this one, we update, this is the old version of the page, and this is the new version of the page. So if you update 3 nodes in this version, you have to read this version and you have to read this version of the page to reconstruct it in memory. And I've implemented it now that it's reading the page fragments in parallel on SSDs, on PCIe SSDs. So hopefully it should not have the biggest impact. But that's a versioning algorithm on the data page fragments.
So you're doing copy on write on page level, and you copy all the page if just tuple changed.
No, that's if just a tuple is changed, you just copy this tuple into this page, and you have also this page, and you have to read the both pages to reconstruct the page in memory. And the cool thing is the sliding window algorithm, which basically reads up to n page fragments. But usually in a versioning system, you have like incremental or differential versioning. So in case you don't want probably to have a long chain of incremental changes, up to a certain point, you would maybe do a new snapshot of the page. But this but this sliding snapshot, this trails the full snapshot into the other page things basically. But it's hard. It's maybe hard.
No. I mean it's hard in implementation, but I think I understand how it should work. I see. Okay, so I understood what is a little better how it works. I see that your database have like 60 or so contributors. The main contributor is obviously you. And third and second and fourth contributors are bots. But there are so many people who work on SirixDB. How do you manage to create this? How did you manage to create this community? Why do they contribute to this database?
I mean, it's not really, the database is not really production ready. And I think we are getting contributions from some people, sometimes a little bit, but they contribute like they fix one issue and they are going away. So usually we have some people which fix one issue, but it would be cool to get some core contributors.
I saw there are like folks who contributed like 30 or so commits, so it's 30 changes to the database. It already sounds good. For example, in my old work in Postgres through 6 years is 70 commits now. So
okay.
it's all what I have done through 6 years. So someone with 30 commits sounds like a really really big investments of time. How did you manage to attract those folks? I understand that it's difficult to convince someone to develop something new with you. How do you're a leader for these folks? How did you manage to do that? It happened. It just happened.
But usually the issues they are going to fix are not database specific issues. So it's like contributing to a Docker file or Docker Compose file or something like that, for instance. So I don't need to help a lot, I think.
I see.
Okay. And I can the secondary indexes. There are a couple of secondary indexes which are user-defined, which are also stored in other tries in the leaf nodes of the tries. So basically, it's not very efficient as of now because the real data structure is a balanced binary tree. So it's not really cache friendly if it's reconstructed from the leaf nodes. But we could also use something like the adaptive radix trie or the height balance trie, which is an improvement, I think, over the adaptive radix trie, maybe.
Okay. I want to ask you, like, you're learning new things, how do you find new information? How do you find ideas for your future work? What do you read? Maybe you can recommend something to our audience.
Basically, like for instance, Gavin, I'm also hearing or watching the YouTube videos from Andy Pavlo,
Yeah.
for instance. I've read some books about the topic and a few papers. The
Maybe
books
you
is
can say that this is best book or this is best paper. What would you recommend? Or this is best blog, or this is best TikTok, or this is best, I don't know, anything, any resource.
I think in one of the blogs I'm reading is the database architects blog, but I think the entries are pretty not so often.
Yeah, it's Thomas Newman. Neumann.
Yeah. And Victor Leis, I think.
Okay, so I will put a link under the video.
And what I also really liked is the data intensive applications book.
Klepman's book with
Martin.
Okay, I will put links there. How do you think like how long are you going to work on databases? Will it be a hobby, or maybe would you like to create a company that is working on like services for SirixDB, or maybe you would like to create a cloud offering of SirixDB, or what best future for a database do you see?
Yeah, actually, it would be really nice to get to work on the project, not only in the spare time, but also at work for work. But I think it's pretty hard to get some users or customers.
So you think that not venture finances and not like company first, but users first. You want someone to use your database, and then
yeah, I think at first it would be cool to get a community around the product, but I don't know. I'm working on it since.
I think so many successful databases, they started with a company, then starting with a product, and only then they got their first users. But I'm not sure in this. How, for example, I don't know, MongoDB was first a company, then a product, or I don't know, maybe Postgres was a community and then a company.
Okay, but I think in Silicon Valley you get a lot of money from investors, but in Germany you don't get a lot of money.
I think it's okay. So
I don't know.
If some investors are watching us and you are looking for new database, here is the SirixDB. This is a chance for investors to try to invest in your database for first round. Actually, anything with like seed investments, it's cool for investors. Okay, I think I asked most of usual questions. Maybe you would like to add something or show us something or say something to audience.
Maybe I can just show what I can show is the on-device layout maybe.
Cool. Let's look at this.
It's actually these are two files. One file is the data file. And every time you're doing a commit, it's basically rewriting two header files, which are just two copies of the same header. And then the page fragments, which are what I didn't tell us that we have a single writer and multiple readers. So the per resource. So on each resource you can on a commit, basically the page tree which is modified is synced to disk in a post order traversal. So from the left bottom to the top. And the last thing is, the second to last thing is the new revision root page, which is written, and afterwards the headers are written. But we don't need a write-ahead log to be consistent, because basically a zero revision is bootstrapped, and afterwards if something fails in between writing this, you can still reconstruct the revision before. So we can just truncate the file to the old revision if something went wrong during a commit.
But you have to know what's the point of truncation should be.
Yeah, we know which was the last committed revision. So we also know how much to truncate, because we know its position in the file. And then afterwards, a second file is written with the headers duplicated again, and there's an array of timestamps and offsets is written, and this file is always read into memory, so we can do binary search on the array to find the revision root page for either for the timestamp, or if you have the revision number instead of a timestamp, then you can simply search for the revision number in this array in memory. So
and you name it device layout, so you are not working on file system level, and you aim at working with raw device, or
yeah,
you just
maybe
file.
maybe I should change this, but currently they are files, but maybe we can store it elsewhere.
I think it's reasonable to work with file system, because like sometimes it's hard to adapt back to raw devices when you already depend on file system guarantees. But at the beginning, it saves you a lot of time invested in working with raw devices without falsified systems. So for me, if I would start a new database now, I would definitely work on top of file system. File system solves generic questions that I don't want to solve, and it solves it well. Do you use any kind of compression in your database?
Yeah, actually, as of now, we are sometimes using bitmaps for the secondary indexes for the node keys which are stored. So it's not a clustered index, but you have to fetch the node keys, and then you have to fetch the real node over the document trie. So the data is not duplicated.
I see. The one other thing
and another compression we use for the pointers. I'm compressing the pointers a little bit. I don't know the English term, but it doesn't matter. But the real compression is maybe with Snappy on the page fragments. So we also compress the whole page fragment. And yeah, I think one thing for the future might be because the page fragments are not of a fixed size, but they are word aligned for now. But I think it would be great to have different I don't know, buffer pool sizes maybe as in UmbraDB, because it would maybe be better for I forgot for the I/O stuff for the new in the Linux kernel. How is it called again?
U-ring, you mean?
Yes, I/O U-ring, because you can pre-allocate buffers, I think. And for this system now, I haven't seen any. I've used the Java library for I/O U-ring, but I haven't seen any performance gains. So it's a bit.
One thing that when I'm looking to the design of your database, it's one thing that I think should be improved is that your database is like, yeah, it's fine for embedded system, but if you want to use it in enterprise level, you need something like replication. And if you don't have write-ahead log, it's hard to build replication without write-ahead log, because you need to log something to ship to another node. Without it, it's hard to guarantee any availability in modern environment. So typically, if you deploy a database in the cloud, virtual machine can go down without a reason, and database is lost in this case, or at least unavailable for a very long time. So it looks like for any new database, replication is very, very, very desired feature. But for embedded database, it's fine without replication. So if your database lives in a cell phone and the cell phone is lost, okay, database is lost too.
Yeah, that's also one thing which is it can be used as an embedded database system in, but I guess only from JVM languages as of now. So
I think it's not a restriction. Many devices like already watches support Java and SIM cards support Java. So any computer can run Java. It's not a problem.
Otherwise, there's a REST API with an HTTP server. Might not be the best choice. I don't know.
HTTP is a great protocol actually, and it solves a lot of problems. In Postgres, we have a problem with the persistent connections. HTTP solves it right from the start. You don't have persistent connections. You have request response. Okay, Johannes, thank you so much for taking the time and describing SirixDB. It was very insightful, interesting conversation. If you don't mind, I will put this recording to YouTube. I think it's okay. And thanks everyone for watching Byte Relay. Auf Wiedersehen.
Tschüss.